Welcome to another video, the same every time. GCSE Maths and GCSE Maths, looking at the kind of questions that, apart from the numbers, are the same every time. So in this set of videos, we're looking at three-dimensional Pythagoras theorem and trigonometry. Well, it's another fairly high-end topic, and there might be some students who look at this kind of question. They see the three-dimensional shape there, they see the 6 marks, and they might think, well, I'm going to move on, I'm going to look at a different question instead. Well, that's not really the approach that we need, because if we break this question down into smaller pieces, we find that we have the skills to do this. So there's the diagram showing a prism, triangular prism, A, B, C, D, E, F. Remember, the letters are just the labels they give for the corners, the vertices, so A, B, C, D, E, F are the corners. They tell us in the question the various lengths of the edges, A to B 13 centimeters, A to C 20, C to F is 24. Angle ABC, start at A, move to B, then to C. The angle that they've marked as a right angle there at B, so that's 90 degrees. Calculate the total surface area of the prism. Well, if we're calculating the total surface area of a prism, what we need to do is calculate the area of each face and add them all together. And if we have a prism, all of the faces are going to be rectangles, apart from the front and the back, which frankly could be any kind of flat shape at all. In this case, they're triangles. So let's see exactly what shapes we have here for the faces. We've got this triangle here at the front, and then at the back we should have, slightly went off with my line there, didn't I? We should have an exactly the same triangle at the back there. I'm really going to draw that one a little bit better. So at the back we have this triangle here, which is exactly the same. So the front and the back faces are both triangles, and they're both exactly the same. So we need to work out the area of that triangle and multiply by 2. Area of a triangle, of course, base times height divided by 2. So there's my right angle. So the height would be 13 centimeters. The base distance, however, is not given to us. So this is the first point in this question where we have to do a calculation. The length from B to C, they don't give us, but we can recognize we're working with a right angle triangle. 2 sides are given, the 20 and the 13, and we need to find the missing side. It's a Pythagoras theorem question then, so it's going to be one of the shorter sides. The longest side is given to us, it's 20. So square, square, subtract square root, and that will give us the missing side just there. So 20 squared minus 13 squared. Okay. So on my calculator, 15.19868,415. Remember, I've said this many times before, we don't want to be using rounded answers in calculations. So if we are using a number again in a calculation, either we are going to be using the full calculator answer, or you need to be going for, let's say, 5 places after the decimal point. So there we are. I'm going to go with 15.19868. That will be enough accuracy for the rest of the question. So on my diagram here, 15.19868, or you can go for the full calculator answer if you want to. So for this one, we need the area of this triangle, which is going to be base times height. So base times height divided by 2. And because we have one of those triangles at the front and one of those triangles at the back, I need to multiply that answer by 2, and that will give me 197.58289. I used the full calculator answer for that calculation for the 15.19868 because that was still on my calculator. I've written this one down to the first 5 places after the decimal point. We are going to have to use that again in a calculation, so we don't want to be rounding too early. So far then, in my calculation, I've got the front triangle face plus the back triangle face. Now that I've considered the front and the back, every other face will be a rectangle. So let's think about, doesn't matter which order we do them, I suppose, the base. So of course in the picture it does not look like a rectangle because it is a 3D shape drawn onto a 2D surface. But what we have there, the base of this shape is going to be a rectangle. There's my rectangle. I'll draw it up again just here. And one of my sides is 24 centimeters. That's from C to F. And the other side, the B to C, is the calculation that we just did. So 15.19868. So the area of the base, it's a rectangle, so it's just going to be 24 times 15.19868, and that will give me the area of the base, which is that. So let's just keep that there for the moment, because our final move in this question is going to be to add together all of the areas of all of the faces. So which face to do next? Well, let's do this one, the sloping face then. Of course, it's another rectangle. All of the faces, apart from the front and the back, which are triangles, they are rectangles. So we have this rectangle here. I'll sketch it up. And one of the dimensions is 24, and the other side, length, width, whatever you want to call it, is 20. So the area of that rectangular face is just going to be 24 times 20. So we don't have the decimal number to work with there. So that is going to be 480. And the final face, we have 3 rectangular faces, don't we? The base, the sloping side, and then we have the back, which is this, or the left-hand face, depending on how you want to describe it. So we have that rectangle just there, and let's see, we've got A to B there is 13, so that would be there, and the B to E, this side just here, that's the same as this, isn't it? So that would be 24. So the area of that face, 24 times by 13, and that will give us 312. So now to find the total surface area, all we have to do is add together the area of all of the surfaces. So here we go, the area of the 2 triangles, the front and the back triangle. Remember, I did multiply by 2, so this does include the 2 triangles. We need to add that together, 197.58289. And then this one is the base, so plus 364.76832. And then the sloping side there, which is 480. And then the left-hand rectangular face, 312. Adding all of that together will give us our final answer. And this is what I get for my final answer. I get 1,354.35121. I'm going to write down what it says on my calculator, and then I'm going to go back and check the question because sometimes they tell me to round to a certain degree of accuracy. In this question they don't. In that case, you need to be looking at the front of your exam paper and seeing what it says about rounding your final answers. I know on the Cambridge paper it says that non-exact numerical answers should be rounded to 3 significant figures. So I'm going to write down what it says on my calculator. And remember, in the mark schemes, whenever they have a question like this, they're never looking for a specific answer unless they tell you to round it. They always allow a particular range of answers. So I'm going to leave my calculator answer there so I can show that I've actually got my answer. But I am also going to round it, and I'm going to round it to a sensible 3 significant figures. So 3 significant figures is going to be 1, 3, 5, and then 0 centimeters squared. It says that in the answer place, but I'll write it again. So centimeters squared, 3 significant figures. Well, there's a lot going on in that question. It's a lot of work, but ask yourself this question: is it actually difficult work? The only really high-end mathematical part of the question was finding the length from B to C, the 15.19, where we had to do a little bit of Pythagoras theorem. Everything else was area of a triangle, area of a rectangle. You have to keep track of the numbers, and remember, don't round too early and don't be using rounded answers in calculations. Either go for the full calculator answer or at least write down 5 digits after the decimal point. Let's see what's happening in the rest of this question. So part B, calculate the volume of the prism, and part C, calculate the angle that AF makes with the base. Right, well, part B is worth 1 mark. It is reasonably straightforward, isn't it? Volume of a prism, area of the end, or area of the front face, or area of the cross section, multiplied by the length or multiplied by the height, depending on what you want to call it. So the volume of the prism is going to be the area of the front face. So the volume equals the area of the front face, which is base times height divided by 2. So base would be this, times by height, which was 13. So there's the area of the front, that's the area of the cross section of the triangle just there, multiplied by the length or the height, depending on what you want to call it, which in this case is 24. So that multiplied by 24. So I get this. I'll write down my calculator answer, and then in the answer space I am going to round it to 3 significant figures, which in this case is just 2, 3, 7, and then the 0 to fill up the space. So 3 significant figures. Remember, I just said this, on an exam they would allow a range of answers for this one. So as long as you're within the range, they will be happy. They're not telling us to round in a particular way, so we go with what it says on the front of the paper, which for a Cambridge is 3 significant figures, or a sensible degree of accuracy if it does not say on the front of the paper. Now, part C, we're getting into slightly more difficult territory. Calculate the angle that A to F makes with the base BCFE. So the angle between A to F, so A to F is this diagonal here in the sloping face, and whenever they are asking for the angle between a line and the base, they mean the diagonal in the base. So the base they call BCEF, which is just the rectangular base at the bottom, so they actually mean the diagonal. So the line from B to F, and you need a bit of imagination here to realize that that would make a right angled triangle. So the angle just there would be a right angle. The angle that they want, the angle between the line from A to F and the diagonal in the base, is this angle just here. Right, so what we have is this triangle. If I draw it up again, there's my triangle. And we have a 13 just there. We want this angle. So we're going to be using trigonometry, and we are going to need another side. So I'm thinking probably the best one to calculate is from A to F. So here's my rectangle, the sloping rectangular face. So that would be A, that would be D, that would be F, and that would be C. And I've drawn in on my picture on the left-hand side there, the line from A to F, which is this line just here. So I have drawn up, if we can see it, this rectangle just here and this line. So the length of that side just there is 20, which is the length of this side there from A to C. And the length of this side from C to F is 24. That would be 90 degrees because it's a rectangle. So if I want the length from A to F, it's a Pythagoras theorem situation because I have a right angle triangle, half a rectangle, and it's the longest side, so it's square, square, add, square root. That will give me the length of the diagonal from A to F. So let's just see what that is. 20 squared plus 24 squared, square rooted, gives me 31.24099. Okay, I'll probably be able to keep the calculator answer on my calculator there, but I'll just write down the first 5 digits after the decimal point. So I've worked out the distance from A to F. So there it is on a slightly cleaned up diagram. So the distance from A to F, and I've written down the full calculator answer there as well. On my pull-out diagram here, I've got the same distance, 31.2409987, and I'm needing to find that angle. Well, what sides have I got here in this right angle triangle? Let's see. That would be the H side, wouldn't it, opposite the right angle, and the 13 is the O because that's opposite the angle that I'm interested in. So we're using sine, so the missing angle, or the angle they want, is going to be inverse sine of O over H, so 13 over 31.2409987. And that number is still on my calculator, so I can use my full calculator answer. So inverse sine of 13 divided by my answer. And it's been a long question, but here we are. So my final answer for this one is 24.58989592. I'm writing down my full calculator answer, but I'm also going to round my answer when I put that into the answer box there. Remember on the Cambridge paper, they do say to round angles in degrees to 1 decimal place. Always, however, go back to the question, just check to see if they are asking you to round in a particular way, because they do that sometimes. And also, I'm talking about the Cambridge exam here because this is from a Cambridge paper. If you're doing a different paper, do have a look on the front and see what level of accuracy they want you to round to. If they don't say anything about accuracy, write down your full calculator answer, and then maybe 1 decimal place in terms of angles in degrees is a sensible degree of accuracy. Well, that was a very long question, wasn't it? And quite a lot involved. Just go back and have another look at the video. Was this question really as difficult as it looked? Or did it just involve a lot of work around mathematical concepts that we are reasonably familiar with? Well, thank you very much for watching, and I do hope that video was useful to you. And if it was useful to you, you know what to do. Like and subscribe, please, because that's actually useful to us. So thank you very much for watching, and I will return with the next video.